So, in the previous lecture, we have discussed about the atmospheric stability, right? Now, in this lecture, we discuss the various plumes types. Okay, so basically, the plume types are important because they help us to understand the under what condition there will be the higher concentration of the contaminant at the ground level, right? Okay, here on screen you can see that the various graphs are given, which is the types of the plume with respect to the atmospheric stability, right? So this is how it is connected with the plume and the atmospheric stability. So basically there are 6 types of the plume. The first one, which is the looping, then neutral plume, coning plume, then fanning plume, lofting plume, and the fumigating plume, right? Okay, and here you can see that the environmental lapse rate and the dry environmental lapse rate, it means that atmospheric stability which is connected with the plume, right? So now we will discuss the various plume and the environmental stabilities in the detail. Okay, the first one, which is the looping plume. So basically it is a high degree of convective turbulence, right? Here you can see that the turbulence are formed, right? This is a super adiabatic lapse rate because it is a strong instability, right? Strong instability condition. Okay, it is associated with the clear anytime condition accompanied by the strong solar heating and the light wind. Okay, then it is occur in unstable atmospheric condition. Okay, when the environmental lapse rate, okay, is less than the adiabatic lapse rate, which is cooler at the less than 9.8 degrees Celsius per kilometer, and the air is stable and there exists a vertical motion. Okay, here you can see that the environmental lapse rate, which is less than the dry environmental lapse rate. Okay, so this is a looping plume, and this is a sub adiabatic lapse rate, right? Okay, now the air that is the here, the air which is that is lifted vertically will remain the cooler, right? And therefore it is a more dense than the surrounding air. And once the lifting force is removed, the air that has been lifted will return to its original position, right? So that it is a stable condition. So the stable condition will be occur at the night when there is a little or the no wind are there. Okay. Now, the second one, which is the coning plume. Okay, so what do you mean by coning plume? It is a stable with small scale turbulence. Okay, so here you can see that the small turbulence are formed, right? So it is associated with the overcast moderate to strong wind. Then it is roughly 10-degree cone. Here you can see that the shape of the plume, which is a cone shape, right? Then pollutant will travel through fairly long distance, reaching a ground level into the significant amount. Then it is occur in the neutral atmospheric condition because here you can see that the both line are equally same, right? So when the environmental lapse rate is the same as the dry adiabatic lapse rate, the atmosphere is state of the neutral stability, right? So the vertical air movement is neither encouraged or the neither or not the hindered, right? Okay, here on this screen you can see that the environmental lapse rate and the dry adiabatic lapse rate will be the same. So the neutral condition is important as the dividing line between the stable and unstable condition, right? So the neutral stability occurs on the windy ways or when there is a cloud cover such that a strong heating or cooling of the earth's surface is not occurring, right? It is a neutral condition. It means that no chances of the rainfall, right? Okay. Now the next one, which is the fanning loop, it means that it is occurred under the large negative lapse rate. Okay, so it is a strong inversion at the considerable distance above the stack, extremely stable atmosphere, and the little turbulence are there. Okay, this is a little turbulence are there, and if plume density is similar to the air, they travel downwind at the approximately the same, right? Okay, here you can see that this is a stable condition are arising, right? Here the plume density is similar to the air density, right? Now the next one, which is the lofting plume. Okay, it is a favorable in the sense that a fewer impact at the ground level, right? So the pollutant go up to into the environment, then they are created when atmospheric conditions are unstable above the plume, and after that they are stable the below, right? So here on this screen you can see that here the inversion will be the occur, and they are created, the atmospheric condition are stable when they are created, and after that the plume are stable the below, right? Okay, here this is, you can see that after that they are stable and stable the below. This is a lofting plume. Okay, now the fumigation, it means that the most dangerous plume, it contaminants are all coming down to the ground level, then they are created when the atmospheric condition are stable above the plume and unstable the below, right? Okay, because of they are contaminant, we are coming down at the ground level. So at the ground level they are stable condition, sorry, above the ground they are stable condition, and below the, which is the unstable condition, right? So this happen with most often after the daylight, sun has warmed the atmosphere, which turn at night time fanning plume into the fumigation for about a half an hour. Okay, so here you can see that the inversion will be the occur, and above the plume the atmospheric stability will be the atmospheric condition will be the stable, and the below the plume the atmospheric condition will be the unstable because of the high concentration of contaminant at the ground level. Okay, here in the first slide we discuss the various types of plume with respect to the atmospheric stability. Okay, here you can see that now you will understand the what is the graph says, right? Okay, now the next topic, which is the control of the air pollution. So basically the air pollution cannot be fully abated but can be controlled if certain measures are taken, right? So it is divided into the two types. First is preventing measure are taken, and the second one, which is control measure are taken, right? The control of the gases or particulate matter. In the control measure, there are control at a two way. The control of the gaseous pollutant and the control of the particulate pollutant, right? And the next one, which is the from industries or automobile using equipment, right? Okay. Now the first part, which is the preventing measure. Okay. So the first of all, this measure are mainly aimed at a correction right at the source. So that will be the lesser amount of the pollutant emitted from the industry or any other sources, right? So here some of the important preventive measure, which is using a low sulfur coal in the power plant, then using a natural gas in place of the coal or for the power generation, then using a LPG or CNG instead of the diesel or petrol in the automobiles, modification in industrial process or equipment to reduce the emission. Then section of suitable site and zoning for the industrial unit. Like a zoning means setting aside a separate area for industry so that they are far away from the residential area, right? It means that we make a zone, residential area, then commercial area, then industrial area, right? So the residential area will keep away from the industrial area so that the pollution will be the lesser. So this will help in the proper dispersion of pollutant, resulting in the lower concentration of pollutant in the air of residential area, right? So by using a proper environmental impact studies before setting the industries. Okay, the next one, which is the control measure. So basically the most common method of eliminating or reducing the pollutant to the accepted level, which include first one, which is the collecting the pollutant by using the equipment to prevent its escape into the automobile atmosphere, right? Now, the destroying the pollutant by the thermal or the catalytic combustion. Then changing the pollution to less toxic form, right? So this is the method, or this is a way we use for the control the pollutant, right? So by releasing the pollutant through tall chimney for greater dispersion, so the tall chimney will liberate the pollutant beyond the inversion layer, thereby reducing the concentration of pollutant near the source, right? But the liberated pollutant will settle somewhere and cause the air pollutant even far away from the sources. Okay. Now, the first one, which is prevention is better than cure. We know that, right? So the ones can prevent the air pollution. For this purpose, some of the example are given. Okay. So we check the example. The first one, which is controlling the spread of coal dust by sprinkling water on it before handling into the thermal power plant, right? Then preventive maintenance by the repairing leaky valve in the advance, so as to prevent the leakage of the harmful gases in the air, right? Then applying zoning to distribute the impact of air pollution in the community. The last one, which is selection of proper material, for example using a low sulfur coal, which reduce the problem, right? So this is the control measure, and the sentence will be fulfilled. Prevention is always better than cure, right? Okay. In addition to preventive measure, one has to have a control technologies is follow. So depending upon the situation, different control technology are adopted. For the dealing with the particulate matter, for the following control technologies are used, which is settling chamber, then cyclone separators, then fabric filters, electronic precipitators, and the wet scrubber. Okay, it is a weight collector also. Okay, so in the first two of the above are used to the coarse particles, whereas other three are used for the fine particles, right? Okay, so this all are the equipment which are used in the industries for the control the particulate matter or control the gaseous pollutant from into the atmosphere, right? Now we will be continue this equipment in the detail in the next lecture. Okay, I hope you all understood about the today's lecture, the various types of the plume and the various plume behavior and how it is connected with the atmospheric stability, right? Now, thank you for the watching. Thank you.